Good day, everyone. I am Yuveli L. Bojardo, and today we're going to discuss about the fundamentals of hypothesis testing one sample test. So in this chapter, we're going to learn about the basic principles of hypothesis testing. Second one is how to use hypothesis testing to test a mean or proportion. Third one is the assumption of each hypothesis testing procedure, how to evaluate them, and the consequences if they are seriously violated. Next is how to avoid the pitfall in hypothesis testing. Then last one, the ethical issues involved in hypothesis testing. So first, let us define what is hypothesis testing. So hypothesis testing is a procedure based on a sample evidence or probability used to test claims regarding a characteristic of population. A hypothesis is a claim or statement about a characteristic of a population of interest to us. And a hypothesis test is a way for us to use our sample statistic to a specific claim. So let's have an example. 2 years ago, the proportion of infected plant was 37%. We believe that a treatment has helped, and we want to test the claim that there has been a reduction in the proportion of infected plants. So that is an example of hypothesis testing. So now, let us move on to the components of hypothesis test. So first, let's have the null and alternative hypothesis test. So let's have the null hypothesis. So null hypothesis is a statement about the value of population parameters such as the population mean or the population proportion. It contains the condition of equality and it's denoted as H naught. For example, H naught of the population mean is equals to 157, or H naught of the population proportion is equals to 0.37. So this is one of the example of null hypothesis. So now let us discuss about the alternative hypothesis. So alternative hypothesis is the opposite of the null hypothesis. So alternative hypothesis represents the conclusion reached by rejecting the null hypothesis. So null hypothesis is rejected when there is no sufficient evidence from the sample data that the null hypothesis is false. If the null hypothesis is not rejected, you should believe that the process is working correctly and therefore no corrective action is necessary. An alternative hypothesis is also known as the directional or research hypothesis. It is called directional hypothesis because it has to contain a strict inequality that it must be a statement that uses less than, greater than, or not equal. And it's called research hypothesis because the process of statistical inference seeks evidence to support this hypothesis. So next, let us discuss the critical value of statistics. So critical value can be defined as a value that is compared to a test statistics in hypothesis testing to determine whether the null hypothesis is to be rejected or not. If the value of the test statistics is less extreme than the critical value, then the null hypothesis cannot be rejected. However, if the test statistics is more extreme than the critical value, then the null hypothesis is rejected and the alternative hypothesis is accepted. In other words, the critical value divides the distribution graph into the acceptance and the rejection region. If the value of the test statistic falls in the rejection region, then the null hypothesis is rejected. Otherwise, it cannot be rejected. For example, here we have our critical value. Then this is where the region of non-rejection, if it falls here less than extreme, so it will fall here. And the region of non-rejection, if it is more extreme, so it has more than here in our critical value, then it will fall to the region of rejection. So a while ago, I've shown a graph that has a region of non-rejection and region of rejection. So let us discuss what is the regions of rejection and non-rejection. So the sampling distribution of the test statistic is divided into two regions. A region of rejection, sometimes called the critical region, and the region of non-rejection. If the test statistics falls into the region of non-rejection, you do not reject the null hypothesis. And it falls in the region of rejection, then we're going to reject our null hypothesis, and then we're going to proceed in our alternative hypothesis. So the region of rejection conceals the values of the test statistics that are unlikely to occur if the null hypothesis is true. So these values are much more likely to occur if the null hypothesis is false. Therefore, if a value of the test statistics falls into this rejection region, you reject the null hypothesis because the value is unlikely if the null hypothesis is true. So, to make a decision concerning the null hypothesis, you first determine the critical value of the test statistics. The critical value divide the non-rejection region from the rejection region. Determining the critical value depends on the size of the rejection region. The size of the rejection region is directly related to the risk involved using only sample evidence to make decision about a population parameter. So if we're going to test, or we're going to have some samples that we only assume it, or maybe we just do some magic about our examples, and then if our professor or anyone that is professional are going to test it, so using this kind of graph, they will know if you did some magic or you've done some investigations or gathering some informations that your hypothesis must be correct or true. Thank you.
So good day everyone. In continuation in Jovial Lee's presentation, so my topic is risk in decision making in hypothesis testing. So let's quickly break down the risk and the two key ways we make decision using hypothesis testing. So what is the risk and in this process? Well, hypothesis testing helps us decide based on sample data, but samples aren't perfect snapshots of the whole population. So this means our decisions can sometimes be wrong. And also, we face the two main risks. First is the type 1 error where we mistakenly reject a true idea, or it is also known as a false negative, and a type 2 error where we fail to reject a false idea, also known as a false negative. So example. So think back to our bottle filling machine. A type 1 error would be wrongly concluding the machine is off when it's accurately leading to unnecessary fixes. Then Next topic is all about hypothesis testing using the critical value approach. So now let's take let's take a look at the critical value approach. So what is it? It is setting a strict boundary. We calculate test statistics from our data. Think of it as a measure of how unusual our sample is. Then we compare it to a critical value, a threshold determined by our chosen level of risk. Then example in critical values. It if ours if our test statistic goes beyond this critical value, we say our sample is unusual enough to reject our initial idea. So in our example, negative 1.0 was extreme enough to cross the positive negative 1.96 threshold, so we didn't reject the idea that the machine was accurate. The next topic is hypothesis testing using the p-value approach. So next up in the p-value approach, instead of a fixed boundary, we calculate the p-value. It is the probability of seeing our samples results or even more extreme ones if our initial idea was actually true. So example in p-value approach. A small p-value means our results are unlikely if the initial idea was correct, so we reject. In our case, the p-value was 0.3174, which is not a small, less than our risk level of 0.05, so again, we didn't reject the idea about the machine's accuracy. In conclusion, so both these approaches help us make decisions while acknowledging the inherent risk in using sample data. They just use slightly different ways to weight the evidence.
Good day everyone. I will be discussing about the relationship between confidence interval estimations and hypothesis testing. These two are essential two sides of the same coin. Confidence interval provides a range of particular values for a population's parameter. The mean based on our sample data. On the other hand, hypothesis testing involves checking if specific claim which we call null hypothesis about a population parameter and supported by the data. The both rely on similar calculations such as T statistics and I statistics. One method can inform the other. For instance, if a hypothesis values falls outside the confidence range, this is the strong indications that we reject the null hypothesis and a corresponding hypothesis test. And that's all about the confidence interval and hypothesis testing. Again, we will be discussing about knowing the population standard deviation. So moving on, the population standard deviation is in real-world scenarios. So we almost never know the true population standard deviations denoted by sigma. Naka-provide na siya sa PPT. Makita ninyo siya unsa ng sigma. So this because of a sigma is a proper of the entire populations, which is typically too large to measure completely. So instead, we estimate sigma by using the sample standard deviations denoted as S. These values calculated from a sample drawn from the population. So this accuracy of the estimate depends on the sample size. Larger samples generally provide more accurate estimate. So only very small and easily measurable population can we truly know the actual population's standard deviations. Otherwise, we rely on our sample to make the best estimate. So that's all about knowing the population standard deviation.
T-test of hypothesis for the mean or unknown. The t-test of hypothesis for the mean is used when the population standard deviation is unknown. Instead of standard deviation, sample standard deviation is used. To understand the t-test hypothesis for the mean, I have some example problems here with a solution. A researcher wants to test if the average height of the students at a certain university is different from the national average of 68 inches. They collect a random sample of 25 students and find the sample mean height is 70 inches with a sample standard deviation of 3 inches. Test the hypothesis at a significant level of A equals 0.05 ED. So this is the solution, the example problem that I give. So the first thing we must do is to state the hypothesis, where the given has null hypothesis, which is 68 inches. The average height is equal to the national average. Then the alternative hypothesis, where is 68 inches, the average height is different from the national average. This is a two-tailed test. Then the second one is set the significance level, which is A equals 0.05. Then number three, calculate the test statistics. We'll use a one sample test since the given is unknown. So this is the formula where sample mean is 70 inches, population mean from the given as 68 inches, as a sample standard deviation which is 3 inches, and sample size is 25. Plugging the values, t equals 70 minus 68, in parentheses 3 divided by 25 equals 2 divided by 3, fifth equals 10 divided by 3 equals 3.33. The next is number 4, determine the degrees of freedom. Degrees of freedom equals n minus 1 equals 25 minus 1 equals 24. Then number 5, find the critical value using a t-table with 24 and a equals 0.05 two-tailed. We find the critical t-value is approximately 2.064. Then, number 6, compare the test statistics to the critical value. Our calculated t-value is 3.33 is greater than the critical t-value, which is 2.064. It falls in the rejection region. Then number 7, make a decision. Since the test statistic falls in the rejection region, we reject the null hypothesis. Then number 8, our conclusion is there is a sufficient evidence at the 0.05 significance level to conclude that the average height of students at this university is different from the national average of 68 inches. Alternative p-value approach. So instead of comparing the t-statistic to the critical value, we could calculate the p-value using statistical software or a t-table. We find the p-value associated with a statistics of 3.33 and define of freedom equals 24 is less than 0.01, a very small value. Since this p-value is less than our significance level, which is 0.05, we would again reject the null hypothesis.
Of t-test. One sample t-test, independent sample t-test, and the paired sample t-test. When to use one sample t-test? So it is used to compare the mean value of a sample to a known mean value. Example ani is a chocolate factory claims that ang ilahang average weight sa chocolate bars is 50 grams. Meanwhile, sa pag randomly select maski 30 samples lang, and ang mean average ana is 48. So diha na to ma-use ang one sample t-test to see if there is a significantly difference between the two means. Next is independent sample t-test. So when to use it? So it is used to compare means of two independent groups or samples. For example, any is we would like to know the effectiveness of two painkillers. So we randomly select 60 people and divided into two groups. So ang group A is mag-take sa drug A and ang group B is mag-take sa drug B. So from there, makikita na to ang magamit na to ang independent sample t-test to see if there is a significant difference sa ilahang pain relief nga mabati upon taking the medicines. Next is paired sample t-test. So when to use paired sample t-test? It is used to compare the means of two dependent groups. For example, ani is we would like to know how effective a diet is. So, na 30 ka people or 30 ka gusto mag-diet, ang i-weigh before the diet, and exactly kana pud nga 30 ka person i-weigh after the diet. So from there makita nato if naabay significant difference ang ilahang timbang gikan atong primero. So mao na ang paired sample t-test. What are the hypotheses of the t-test? So sa one sample t-test, ang null hypothesis niya is the sample mean is equal to the reference value. So same ra gid siya, equal. Then ang iyang alternative hypothesis is ang sample mean is not equal to the reference value. So nag-differ siya from the reference value. So what about the independent samples t-test? So the null hypothesis of independent sample t-test is the mean values in both group are the same. So there is no difference sa ilang value. Meanwhile, the alternative hypothesis of independent sample t-test is the mean values in both group are not equal, so there is a significant difference sa ilahang value. Lastly, ang hypothesis sa paired sample t-test. So ang null hypothesis niya is the mean of the difference between the two pairs is 0, while ang alternative hypothesis niya is the mean of the difference between two pairs kay dili 0. So it's sabotable naman, di ba?
So I'll be explaining how to calculate the t-value using different types of t-tests. So first, we have the one sample t-test. The formula compares the average of the sample to average of the population. So you subtract the population average from the sample average, then divide it by the sample average deviation over the square root of how many values are in the sample. Next is the independent sample t-test, which is used to compare the average of two groups. So first, you have to subtract the average of two groups from the average of group 1. You have to subtract the average of group 2 from the average of group 1. Then divide that by the square root of the variance of each group divided by how many values each group has. Then the last is the dependent sample t-test. It t-test for the paired data like before and after result. So you get the average of all the differences. You have to subtract 0 and then divide by the standard deviation over the square root of how many pairs they are.
Good day everyone. Today I'll be talking about one-tailed hypothesis testing. In the earlier chapters, we studied two-tailed tests, like when we check if the cereal fill amount was different from 368 grams, or when we tested if invoice total changed from $120. In those cases, we're open to differences in either direction, more or less, so we tested both tails of the distribution. But in one-tailed test, a one-tailed test examines whether a parameter is greater than or less than a specific value but not both. One-tailed test because the rejection region is placed entirely in one tail, left or right of the distribution. So one-tailed versus two-tailed test. Two-tailed test if a parameter is different from a certain value, could be higher or lower. So when we talk about one-tailed tests, we're focusing on situation where the alternative hypothesis is directional. That means, as I mentioned earlier, we are testing whether a parameter is either greater than or less than a certain value but not both. Ang kalayan na yung dua is, ang two-tailed test is we tested both tails of the distribution. Pero sa one-tailed test, isa lang. So here's an example. The population mean is less than a specific value. One such situation involves the business problem concerning the service time at the drive-thru window of a fast food restaurant. The speed with which customers are served is of critical importance to the success of the service. In one past study, McDonald's had a mean time of 174.22 seconds, which was only ninth best in the industry. Suppose that McDonald's began a quality improvement effort to reduce the service time by deploying an improved drive-thru services process in a sample of 25 stores. Because McDonald's would want to institute the new process. So in using the critical value approach, you wish to determine whether the new drive-thru process has a mean that is less than 174.22 seconds to perform this one-tailed hypothesis test. So in critical value approach, we use the 6-step methods. So step 1, we set our hypothesis. The null hypothesis states that the mean service time is greater than or equal to 174.22 seconds, while the alternative states that is less than 174.22 seconds. We're trying to prove that the new system reduces time. So in step 2, we collected a sample of 22 stores and set the significance level at 0.05. So next is step 3. Because the population standard deviation is unknown and the sample size is small, we use a t-distribution. So in step 4, the rejection region is on the left tail. Using 24 degrees of freedom, so n is my n minus 1 muna itong pagkuha sa degrees of freedom. So the critical t value at 0.05 is negative 1.7109 based on the table below. So our rule is if the computed t is less than negative 1.7109, we reject the null hypothesis. So next is step 5. So since we calculated the test statistic using the sample mean of 162.96 seconds and a sample standard deviation of 20.2, as shown in the equation, the result was negative 2.7871. So next is step 6. Since negative 2.7871 is less than negative 1.7109, we reject the null hypothesis. So there's strong statistical evidence that the new drive-thru process significantly reduces service time. So now for the p-value approach, these steps are mostly the same with the critical value approach. So after calculating the test statistics, we find the p-value, which is the probability of getting a result this extreme if the null hypothesis is true. So as you can see on the figure below, the p-value we got was 0.0051. Since 0.0051 is less than our significance level of 0.05, we again reject the null hypothesis. This confirms that the new system reduces service time and there is enough evidence to apply it across all stores.
So this is a step-by-step procedure of a z-test for a proportion under the critical value approach. Step 1, state the hypothesis. So null hypothesis should be population proportion is equal to the hypothesized proportion. So alternative hypothesis, the population proportion is not equal to the hypothesized proportion. Or for the left-tailed, population proportion is less than the hypothesized proportion. And for the right-tailed, its population proportion is greater than the hypothesized proportion. So step 2, set the significance level. Daghan siya significance level, pwede ka mamili, pero the common choices are 0.05 or 5% or the 0.01 or the 1%. So compute the test statistic. Use this formula. Z is equal to the population, the sample proportion minus the population, hypothesized proportion divided by the square root of the hypothesized proportion times 1 is equal to the hypothesized proportion divided by the sample size. So to find the critical value, you need to use the standard Z table. And mo to siyang step 4. And step 5 is make a decision. If Z falls in the rejection region, reject the null hypothesis, or otherwise do not reject the null hypothesis. So step 6, state the conclusion in context. For example, in this problem, a company claims that 60% of its customers are satisfied with its service. A survey of 100 customers finds that 52 are satisfied. At the 0.05 level of significance, test the company's claim. So the solution, so step 1 is the hypothesis. The null hypothesis should be the population proportion is equal to 0.60, and the alternative hypothesis should be the population is not equal to 0.60 or two-tailed beast. So step 2, significance level. This is given that the significance level is equal to 0.05. So step 3, test the statistic. So the sample proportion is equal to 52 over 100. 52 is given katong 52 satisfied customer over the 100 customers is equal to 0.52, and the hypothesized proportion is equal to 0.60, and the sample size is 100. And to compute, i-distribute ra nimo siya sa iyang kanang places dito sa formula, which is the Z is equal to 0.52 minus 0.60 divided by the square root of 0.60 times 0.40 divided by 100, which is the sample size. So, yung answer ni is negative 0.08, then i-divide pa yun nimo og sa square root sa 0.0024, and yung answer dayon is negative 0.08 divided by 0.049 is equal to negative, and yung answer is equals negative 1.63. So step 4, the critical values. Two-tailed test is equal to 0.05, or ang iyang kanang aron makita nimo siya sa Z table man, ang nearest sa 0.05 sa Z table is equals to positive or negative 1.96. So step 5, decision. Calculated Z is equal to negative 1.63 is within the range of negative 1.96 and is less than to Z and greater than to 1.96. Do not reject the null hypothesis. So in conclusion, there is not enough evidence at the 0.05 level to reject the company's claim that 60% of customers are satisfied. Thank you.
The hypothesis testing. First one is a method to compare sample data with population assumption. Hypothesis testing checks if what we see in a small group or sample matches what we expect in the whole group or population. Example, if a company thinks 60% of consumers are happy, but the survey shows 50%, hypothesis testing helps see if that difference matters. And the second is helps make business decisions based on evidence. It helps business make decisions based on facts, not guesses. Example, a company can test if a new and really increase sales increase instead of just hoping it did. And the third one is involve assessing the probability of observing results by chance. It tells us if the result we see are real or just a random. Example, if a sale or go up, hypothesis testing checks if it was because of something the company did or just a look. Statistical significance between a result is unlikely to have occurred by chance, while practically significance considers whether the result is large or meaningful enough to have real-world value. In some cases, especially in large sample sizes, a result may be statistically significant but have a little practical impact. For example, a marketing campaign by increasing brand awareness from 30% to 30.84% with the statistical significant p-value, but the actual increase is less than 1%. In research, it is important to report both significant and non-significant results. You should not only present findings that shows statistically significance and ignore those that do not. When a hypothesis test shows insufficient evidence to reject the null hypothesis, this does not prove the null hypothesis is true. It simply means that based on the sample and data collected, there is not enough evidence to conclude otherwise. The result indicates a lack of evidence against the null, not confirmation that it is correct. Honest and complete reporting of all results help ensure accurate and unbiased research. Next one is the ethical issues. So you need to distinguish between poor research methodology and unethical behavior. Ethical consideration arise when the hypothesis testing process is manipulated. Some of areas where ethical issues can arise include the use of human subjects in experiments and data collection method. The type of this is one-tail or two-tail test. The choice of the label of significance, the cleaning and the discarding of data, and the failure to report permanent findings.